All right, let's do 5.6. Should be a pretty quick one, I think. In 5.6, we're going to talk about the half angle and power reducing identities. So these are the half angle identities down here, and then we've got the power reducing identities up here. And notice that bridges the gap. We've done all of these now, all the way. Well, we didn't really talk about these ones very much. Well, anyway, but we've gone all the way to here. And so this really does it. This is the end of chapter 5. One thing that I want to point out to you is that the half angle identities and the power identities are the same thing when you really think about it. Okay? Half angle identity tells you sine of theta over 2, right? So this is the half angle identity for sine because it's telling you what to do if the angle is being divided by 2. Well, that turns out to be plus or minus square root of 1 minus cosine theta over 2. Now you have to decide, is it going to be positive or negative? And so you have to kind of figure out what quadrant you're working in and all that jazz, right? But just to show you that's the same thing as the power reducing identity for sine. Notice that first of all, if you square both sides, whether this is positive or negative, it's going to become positive when you square it. So you're going to get sine squared of theta over 2 equals just 1 minus cosine theta over 2. And then if you change your perspective a little bit so that instead of looking at theta over 2, you just notice that here, whatever angle is here, I double it there. Well, then you notice that what you would really have is sine squared theta is just 1 minus cosine 2 theta over 2. And that's exactly what this one's saying. Okay? So these are the same thing, right? The power reducing identities and the half angle identities, they're exactly the same thing. And you'll use both of them a lot in calculus, so memorize them. Okay. As far as proving these things go, so proving the power reducing identity, for example, for cosine squared. So notice that by the double angle identity that we talked about in 5.5, cosine 2a is 2 cosine squared a minus 1. You add 1 to the other side, okay, and you get this, and you divide by 2, and you get exactly the power reducing identity. Okay? So that's that. Let's practice applying these. So let's use half angle identities to evaluate the following. Okay, let's do sine of 195 degrees. So to use a half angle identity to evaluate this, what we would need to do is figure out, well, what 195 is half of what angle? In other words, right, you multiply 195 times 2, right? And you're going to get sine of, that would be what? 290, is that right? 195 times 2? No. 195 times 2 is 390. That's interesting. I don't know if I meant to to do this exact problem. Maybe I did. I don't know. But anyway, we can figure out what sine of 390 degrees is. It's not a big deal, since it's coterminal with 30 degrees. But anyway, let's move forward with this problem now. So half angle identity for sine. This is going to be plus or minus square root of 1. Oh, is it plus or minus? I forgot. Oh, I should check it out. It's minus. So for sine, it's minus. 1 minus cosine of 390 over 2. Okay, well, first of all, I can settle the dispute about whether it's positive or negative right away. 195 degrees is in quadrant 3, and sine is negative there. This is going to be negative, right, because, you know, it's in Q3. Okay, this is going to be negative 1 minus cosine of 390 degrees would be the same thing as cosine of 30 degrees, since 30 degrees and 390 degrees are coterminal. Okay, cosine 30 degrees is root 3 over 2. So we get negative root 1 minus root 3 over 2 over 2. You can simplify the complex fraction by multiplying by 2 over 2. You would get square root of 2 minus root 3 over 4. And actually, if you apply the square root to the numerator and denominator, individually you get negative square root of 2 minus root 3 over 2. And there you go. That's the exact answer. Let me give you another one. See if you can do this one on your own. So see if you can do cosine of 15 degrees. Okay, go ahead and give the video a pause. See if you can work that one out. Okay, this is going to be cosine of 30 degrees over 2. So that's going to be plus or minus square root of 1 plus cosine of 30 degrees, in this case, over 2. That's going to be, well, if you're dealing with 15 degrees, that's in quadrant 1. So you're going to take the positive square root there. Okay? So it's going to be the square root of 1 plus root 3 over 2 over 2. That's going to be square root of, same deal as before, right? 2 plus root 3 over 4, or in other words, root 2 plus root 3 over 2. Okay. Here's another one. So given that cosine x is negative 5/8 and x is between pi over 2 and pi, let's find sine of x over 2. Okay, so here we go. We can describe sine of x over 2 in terms of cosine. Right, that's just straight up half angle identity right there. Well, let's see. If we know that x is between pi over 2 and pi, then that would mean x over 2 would have to be between pi over 4 and pi over 2, which would mean that x over 2 is in quadrant 1. And since x over 2 is in quadrant 1, sine of x over 2 is going to be positive. Okay. So this is positive square root. Cosine, we're told, is negative 5/8. And the rest is history, my friends, right? So we're going to have 8 plus 5 is 13. This is 13/8. 13/8 divided by 2 is going to be 13/16. Square root of 16 is 4, so I think we get square root of 13 over 4 at the end of the day. You're welcome to check my math there. In fact, please do. But I think that's the answer you should get. The main point, though, is you know, using this formula. Let's look at another one. Given cosine 2 theta equals 1/2 and theta in quadrant 2, find cosine theta. That's interesting. I mean, but notice that theta is half of 2 theta for sure. So we can still use a half angle identity. You can say cosine theta is plus or minus square root of 1 plus cosine of double the angle you started with, right? 2 theta divided by 2. All right, theta's in quadrant 2. That means cosine theta is negative, right? So this is going to be negative square root of 1 plus 1/2 divided by 2. 1 plus 1/2 is 3 halves. 3 halves divided by 2 is 3/4. Square root of 4 is 2. So I think you get negative root 3 over 2. Very interesting, right? There's probably more than one way to do that problem. In fact there is, of course, right? If cosine 2 theta is... Well, never mind. I don't want to get into it. But yeah, there's definitely another way to do that. Let's practice verifying some identities. This is my favorite. Okay, let's do cotangent squared of x over 2 equals 1 plus cosine x squared over sine squared x. Ooh. Okay, give the video a pause, see if you can do that one. I'm not sure. Okay. The reason I'm not sure is because I'm looking at the cotangent squared of x over 2. I've got a feeling I should start there and try to make it look like the right-hand side, even though the right-hand side looks a little more complicated. But I'm not even sure where I would start on the right-hand side, to be honest with you. Actually, the right-hand side is kind of nice, isn't it? So you could call this 1 minus cosine squared, and then that's a difference of squares. So you could factor it as 1 minus cosine squared would be 1 plus cosine times 1 minus cosine. And then the 1 plus cosine would cancel with one of these. You'd have 1 plus cosine over 1 minus cosine. But where to go from there? That's where I'm stuck, which is why I think maybe starting on the left-hand side in this case, even though it looks like the simpler of the two sides, might be the way to go. The problem is we don't really have like a power reducing identity for cotangent, nor do we have a half angle identity for it. So I almost feel like you've got to rewrite this in terms of sines and cosines, right? Like maybe you can call cotangent squared cosine squared x over 2 over sine squared x over 2. And then maybe do like a power reducing identity on these. So power reducing identity for cosine squared is going to be 1 plus cosine of double the angle, which is nice in this case. That just gives you x, divided by 2. And power reducing identity for sine is going to be 1 minus cosine of double the angle divided by 2. You flip and multiply. There it is, right? You flip and multiply, and you get 1 plus cosine x over 1 minus cosine x. Remember what I said a second ago about like that's what the right hand side is equal to? If you work on the right hand side, you can meet in the middle. But I know the trick because I thought it through a second ago. So I know that if I multiply by 1 minus cosine, 1 plus cosine, that I'm going to get 1 plus cosine x squared in the numerator, which is just exactly what I want, and then 1 minus cosine squared x in the denominator, and there you go. That'll do it. Very nice. Okay, I like it. Here's another one. Let's verify sine 2x over 2 sine x, that one simplifies nice, equals cosine squared x over 2 minus sine squared x over 2. That simplifies nice as well, I think. Give the video a pause, see if you can do it. Okay, here I go. I'm going to start with this guy. Because notice, double angle identity here reveals that it's just cosine x. Okay? So the left-hand side is just cosine x at the end of the day. What about the right-hand side? I'm going to start there now. Apply these power-reducing identities. So cosine squared x over 2 is going to be 1 plus cosine x over 2. And then for sine, it's going to be 1 minus cosine x over 2. Okay, that's 1/2 plus 1/2 cosine x minus 1/2 plus 1/2 cosine x. Just splitting the denominators there. But sure enough, right, the 1/2s are gone. The half cosine x's will become just a 1 cosine x, and there it is. So I think the logic flow would maybe go from here to here, then from here to here, then from here to here. That would be a very tricky one that I don't know how you'd really see unless you were working backwards. From here to here, and then from here to here. Okay, so that's the logic flow. Do we want to do any more of these? Let's do. I do have one more listed here, so let's do it. Tangent a over 2 equals sine a over 1 plus cosine a. Okay, go ahead and give the video. Actually, I just gave that to you. I'm not sure what I intended there. Let's skip it. I gave this to you on your formula sheet. I think maybe what I intended. So notice that under the half angle identities, I give you 3 different options, and that was one of the ones that I gave you. I think what I intended is for you to maybe like use the first one to prove the second one. I don't know. I'll let you do that on your own if you want to try to figure it out. Okay, but that's all I'm going to say for this one.